Here, the torus testbed, which has the Aptronic P170 series elastic actuator. One of the previous iterations was used actually to develop NASA's Valkyrie humanoid robot, which suggests this technology is quite expensive. So it's awesome when you can connect technology like this to the internet and give students the opportunity to learn from this sort of hardware so that they can solidify concepts of dynamic systems and control and further their understanding of theory that they've been learning in the classroom. Through controller design, this series elastic actuator can demonstrate its capability in gravity compensation, impedance control, as well as the ability to follow a commanded sine wave. So when the student first logs into the UT CLAB laboratory, they are greeted by this welcome message and some basic information on what they can do utilizing the site. So as you can see on the left-hand side of the screen, they have access to 3 experiments: system identification, feed-forward control, and feedback control. The student then has access to the last question. Once they submit it, they are automatically redirected to the scheduler, where they can schedule a convenient time for them to have access to the hardware. For example, Monday the 9th works for them. At 10:15 a.m. they go in, they schedule it, and they have their time reserved. Specifically, Cunye is going to be running the system identification experiment on the series elastic actuator that's located in the human-centered robotics lab. We'll get to see the experimental output and compare it against the simulated behavior of the system. So,
yeah, I will run the experiment.
we can see the belt of the series elastic actuator moving, and below it we see the input current versus time being plotted real time. So now about 2 minutes have passed, and now we have access to the experimental output as well as simulated results. So let's scroll down and take a look. We now have the corresponding Bodhi plot from our experiment. So what are the observations you can make about the differences?
Yeah, I noticed some differences between the experimental results and the simulation output. And for example, why does the phase that starts as a negative value?
Well, that's a good observation, and in a real system there are disturbances such as nonlinear drivetrain friction, so that is causing the negative phase that you're seeing at low frequencies.
Oh, I see.
So now you have this parameter of your transfer function ready. So I'm just going to submit. All right, and you guys can do submit on your device. Okay.
Correct. Correct.
So you guys don't need to run, but I can start, so can trigger the experiment. Here we go. And you should be seeing the same thing on your device. And you can hear the sound. Actually, the frequency is getting faster and faster since the experiment is approaching to the end.